In this lab, you're going to be given an unknown, and through a bunch of chemical tests in the laboratory, you're going to identify what the compound is. You'll use both functional group tests, and you'll make a derivative to help identify it. Now, when you get through with this and you believe you know exactly what the compound is, then I'll let you take an infrared spectrum of your compound to see if you are correct. The first thing that you do in identifying the functional group of a compound is that you will look to see if it's soluble in a variety of solvents. 5% hydrochloric acid, 5% sodium hydroxide, 5% sodium bicarbonate, and pure water. The solubility gives you information about the size of the compounds, how many carbons are in there relatively, whether it's a lot or very few, and the functional group. If you look on page 518 of your textbook, the layman textbook, the laboratory textbook, you will see there's a flow chart that shows you how you can use the solubility information to decipher functional groups. Remember, only low carbon numbers, compounds with low number of carbons in them are going to be soluble in water, and it must be with the presence of a hydrophilic functional group. You can have very few carbons like propane, no functional group is not going to be soluble in water. So it must be in combination with a hydrophilic functional group. If you do get a compound to dissolve, one thing that you want to do is test it to see if the solution that it forms is either acidic or basic. If it's acidic, then you feel pretty confident it's either a carboxylic acid or a phenol. If it's acidic, if it's not acidic, it doesn't necessarily rule out a phenol, because phenols are weakly acidic, and sometimes litmus paper doesn't actually show up the acidity of a phenol when dissolved in water. If it's basic, then you know you have an amine. If it's neutral, it could be that you have any number of functional groups that are neutral: alcohols, aldehydes, ketones, etc. So there's a huge number out there that neutral solutions can occur from. You should know these basic solubility principles, but it doesn't hurt to review them. Amines will dissolve in 5% hydrochloric acid. Carboxylic acids will dissolve in either sodium bicarbonate or 5% sodium hydroxide. Phenols will dissolve in 5% sodium hydroxide only, not in sodium bicarbonate. And then there's this cold concentrated sulfuric acid. Cold concentrated sulfuric acid will usually dissolve most compounds that have functional groups, because it just starts tearing them. It's actually reacting with it and tearing it apart. The only compounds it cannot do that to are compounds that are totally hydrophobic with no functional groups. So something like toluene or benzene or hexane, those would not dissolve in cold concentrated sulfuric acid. So it's an indication you have an alkane or an aromatic compound with no functional group. When you do your solubility test, dissolution will occur quickly, let's say in a minute or so. If you set your test tube on the counter and you look at it 10 minutes later and the compound's gone, that is not dissolution. That probably is that the compound's reacting. So you have to be careful in your judgments here. In order to encourage dissolution, you're going to shake, and the best way that I found to shake them is to hold the test tube and wrap it against your fingers violently. It's not so that it spills, but so that you're getting very, very good vibration within the test tube. If you're using a liquid, you're going to use 0.1 mil and 3 mils of the solvent. If it's a solid, you're going to use 90 milligrams. You can weigh out 90 milligrams and see approximately what size that is, and then estimate it from then on. You don't have to weigh it out each time. If you shake it and it's cloudy, or you can see the solid never goes in, well, then you can say, okay, it's insoluble. But sometimes you will, if it's a liquid and it has about the same refractive index as the solvent, what you will find is that you can't see cloudiness. There might be droplets in there, but you don't see it. And this happens a lot. And what I find you have to do is rotate the test tube around and look for a little droplet of oil that might be clinging to the side. And if as you rotate it around it stays in that same place, you can say, oh, it's not soluble. This is just a starting point. It gives you hints as to what the functional groups can be. But remember, every single test you run has to be taken with a grain of salt. The solubility test can be finicky and misleading, and the functional group tests can be finicky and misleading too. So you look at everything as a picture and you try and interpret it together. Now, the reactions that we use, that we have done, these are our functional group tests. For instance, when we looked at SN1 and SN2, we did a functional group test for alcohols. And so we're going to review these type of reactions. And these actually tell us, the results of these reactions tell us what our functional groups are. Again, though, you have to take everything with a grain of salt, and you might get two conflicting positive functional group tests or two negative conflicting functional group tests, and so you have to be careful how you interpret things. Okay, one thing that is the best way to do things is to run a positive, meaning that you have a compound that you know should get a positive result, and a blank, which is that you run the you run the test without adding anything to it, so that you can see what is the difference. And then when you run it with your own compound, then you can see which does it fit closer to, the blank or the positive. So this just helps you interpret your results. One of the first tests you can do is a chromic acid test. Chromic acid is an oxidizer, and what does it oxidize? Primary, secondary alcohols and aldehydes. It does not touch ketones, tertiary alcohols, or carboxylic acids. So a positive test is that the orange solution turns blue-green, and negative is that there's basically no change in color. Again, you have to interpret this within a few minutes of starting the test, because you can have changes occur due to other things. So this can help you either exclude primary, secondary alcohols and ketones, or include them, or exclude ketones and tertiary alcohols. Another alcohol test that you can run is the Lucas test, which is a reaction that we did as trying to figure out if it was SN1 or SN2. This is an SN1 reaction, so only tertiary, allylic, and benzylic react quickly, meaning instantaneously almost. And what you see is the alkyl halide is insoluble in the aqueous solution, so it separates and you see a cloud. Secondary will react, but they react slowly, and primary do not react at all. Water insoluble alcohols cannot be tested this way because they're already insoluble, so you'd never see a change. This is the reaction, the alcohol plus hydrochloric acid and zinc chloride as a catalyst gives you the alkyl halide, which would then be water insoluble. But remember, it only is if you have a water soluble compound that you can test this with. Alcohols also can be tested with acetyl chloride. They form an ester. The problem with doing this is that you have to have good acetyl chloride. It has to be fresh, and it's not the easiest test to run. We only usually run it when all the other tests are inconclusive and you just say, I've got to find out if this is an alcohol or not. Aldehydes and ketones will form a precipitate with 2,4-DNP. This actually forms a derivative. You can collect it and test the melting point to identify what the compound is based on the melting point of the derivative. An orange or yellow precipitate forms, and then you filter it off and you can recrystallize it and get a good melting point. To differentiate between a positive with the 2,4-DNP test and to try to figure out whether that was an aldehyde or a ketone that reacted, what you do is you can run the chromic acid test or the Tollens test. The Tollens test is specific to aldehydes, and the Tollens test uses silver oxide to oxidize the aldehyde to a carboxylic acid, and as a result the silver is then reduced to silver metal, and you see this little silver mirror forms very slowly at the bottom of the test tube. It takes quite a while for this to form, but it'll look just like a little mirror on the bottom of the test tube. And then that's positive for aldehydes. Ketones are not positive in the Tollens test. There is a methyl ketone test. It's called the iodoform test. If you have a ketone and you want to see is it a methyl ketone, meaning that the ketone is a number 2 ketone, the carbonyl is on the number 2 carbon, you can run the iodoform test, which you mix with sodium hydroxide and iodine. This is the same as a bromoform reaction, except it's with iodine. And what's neat about this is you get this bright yellow precipitate when it's positive. Secondary alcohols will also give a positive test because they are oxidized to the ketone and then they undergo the iodoform reaction. Carboxylic acids are very hard to test besides the solubility. The only other thing you can do with a carboxylic acid is to titrate it with a base. There's a specific procedure you can follow to titrate it with a base to give you the molar mass of the compound. It's tough to do because it's a titration, and most students find titrations difficult, but you can do this to help identify your carboxylic acid. Phenols can be identified by the iron 3 test. Iron 3 will complex with phenols to form a red, blue, green, or purple color. It's just going to be an intense color. You don't know what to predict. Other acidic functional groups will give positive results, but carboxylic acids will not. Also, phenols will react with bromine and water. The bromine does an electrophilic addition to the benzene ring, and what you find is the bromine will be decolorized and a precipitate forms. So we just went through a bunch of functional group tests, and you will be using these in the lab to help yourself identify them, and we will go through some examples of how to do this in class, on how to do this so that you can figure out how to interpret results. It's much harder in the lab though because the results aren't quite as clear-cut as paper results.